Hi. So the goal of this video is to talk about the bisection method. And our objective for using a method like this is to try to find the location along a function where the function intercepts the x-axis. Basically, where does f of x equal to 0? This is important because in many cases, we're interested in when a function or some physical behavior is equal to 0, or it's equal to some number. And I guess just to start off, whenever we do any sort of root finding techniques, the prerequisite is that we must be of the form f of x is equal to 0. So if I say something like x squared plus 6x minus the square root of x is equal to 4, and I tell you to find the x that makes that true, we can do a root finding technique on this. But in order to do so, we want to get the right side equal to 0. So I'm going to subtract the 4 over to the other side. And then I say that this thing here that's on the left equal to 0, this is our f of x. And now we're in that form. That is a prerequisite for both bisection method and Newton-Raphson method, which will be in my other video. You can see the link in the comment or in the description below, so you can go to that video after if you want to watch that one. But in general, this is the form that we need to be in. So for bisection method, let's explain the general idea. First, we have to pick two initial guesses. So if I were to draw a picture, let's say, and I have my function, and I don't really know where it touches the x-axis, but let's say I have something like this, whatever. I need to pick two initial guesses for what my root is. Let's pretend that this root value here, let's say that this is 3. X equals 3 is the answer. And maybe I pick two initial guesses. Maybe one of my initial guesses is x equals 4. And then my other one, I'll make x equal to, let me think about this so it's not, let's make it x equals 0 for conceptual sake. X equals 0. You can see that I drew a red dashed line there to signify that our initial guesses for the root correspond to certain function values as well. But what we need out of these two initial guesses is that the function values of those two initial guesses, function values of the initial guesses are opposite signs. What do I mean by that? Well, I don't mean that the x values are different signs, because in many cases, the x values are both positive or both negative. They don't have to be opposite signs. In this case, you have x equals 0 and x equals 4. The signs of those numbers don't matter. What does matter is that the function value at those points, so right here where I'm drawing this dot, this is f of 4. And over here, this point is f of 0. Those two y values have to be opposite signs. Why is that conceptually? Well, if they're on opposite sides of the axis, so if f of, and then what I'm going to do in terms of a definition is say that the lower point, and when I say lower, I mean on the x-axis, I'm going to say that this guy here is the low point. I'll call it x low. And then the high point I will call x high. I'm going to say if f of x low and f of x high are opposite signs, then that means, assuming the function is continuous, that we have to cross the x-axis at some point. Give me a sec. The x-axis at some point. And we can see that in the picture. If you look at the picture, I'll go ahead and use green maybe. I'm at x equals 0. I'm traveling along. If I want to go to x equals 4, which is higher, I have to cross the x-axis at some point. I have to switch signs at some point. So what that tells me is that if they're opposite sign, there's at least one root in between. And the reason I say at least is because let's say my function looked like this, and I picked f of x low, which was negative, f of x high was positive. In this case, I have a bunch of roots. I don't know how many there are, but I do know that there's at least one. Okay, so let me go ahead and copy this graph down. Copy all those words too. I'll just delete them. Come down to here. So we have this known fact, there's a root in between, again, assuming the function's continuous. The bisection method is basically saying, let's look at the middle of this range. So now we'll look at the midpoint between x low and x high. If I am between 0 and 4, the midpoint will be 2. So maybe I'll pick x equals 2 next. And if I do that, what we see now is that there's a sign associated with this new point. So for this example, x equals 2 is the midpoint. And let's say I just draw a number line here. 0, 4. Oh, there's my dog. 0, 4, and 2. I know that the sign at 0 was negative. I know that the sign at 4 was positive. And now, if I go ahead and look at this sign at this new point, which is the midpoint, I can see based on our picture that that has to be negative. Now let's think about this. These are my 3 points, 0, 2, and 4 that I'm interested in. And the goal of the bisection method is to reduce this range and continuously surround our root. Because if we have a range that is 4 units apart, and then we break it down to 2 units, and then we ultimately break it down to 1 unit, then half a unit, and so on, we can basically converge onto the root. And that's our objective here. So if I look at this picture where I have 0, 2, and 4, where's the root? Well, I already told you before that the root was at, x equals 3. But if I'm just looking at the signs of this, if 0 and 2 are both leading to negative function values, we didn't cross the x-axis, at least not that we're aware of. But here, if I'm at 2 and then I go to 4 and I go to a positive sign, the root must exist between those 2 points. And that's my new range. So what do I mean? Originally, the 0 point, this was x low. This was x high. On our next iteration, we want to go ahead and choose a new x low and a new x high. What would those be for this case? Well, 2 is definitely going to replace one of them because of the fact that that is the new point. That's our new estimate for the root. Since it's negative and matches the sign of the 0, that means that the 2 is going to replace the 0. So x low becomes 2 since it's the same sign as the previous x low, which means that the 4 is still here and that will stay our x high. And then we would repeat. So let's just write out these steps. We choose, 2 guesses, which are x low and x high. We find the midpoint. And then we'll replace either x low or x high with this new root estimate, which in my notes I think I call x mean, because it's the average of the points. The midpoint in the situation between these two numbers will be the same as the mean of them. And then repeat. Or repeat, rather, those steps. We have a new x low in this case. We'll go ahead and find another x mean, which in this case is 3. And then we found the answer. Wait. Come here. And then we found the answer. That is the general idea. So let's go ahead and look at the possible cases. Okay, so let's go ahead and look at case 1, which will be a repeat of what we just did. And if you come back up to what we just did, we see that I had an x mean that ended up with a negative function value. Let's go ahead and show what happens there. Let's say that I have a graph where I have some function, something like this, maybe something like that. And I say this is x low, this is x high, and I know that the function value at x high is positive and the function value at x low is negative. So what I mean, f of x low less than 0, f of x high is greater than 0. And I find my mean. Maybe my mean is right here. And in this situation, f of x mean is also negative. So that means when we go ahead and do another iteration, that x mean is going to replace our x low. So just to kind of show what that looks like, I'll go ahead and draw the picture again. Like that. This now, which again is the same as that, this is going to be my new x low, and the point from before, that's still going to be the x high. So I will go ahead and repeat the process now to find a new x mean, which will be maybe like right here, and go again. So that's the case where we replace our old x low with a new x low. Now let's say we're going to draw a different graph. And again, the graphs don't need to look like they're going upwards or anything. It could be any function. Maybe I'll draw something like this time. X low, X high, and maybe I'll make X mean here. Without even worrying about any math, what we can see conceptually is that X mean is having a negative function value at that location. And if you just think about it just kind of graphically, we're trying to bracket this root. So here's the root. Originally it was between X low and X high with the root right in between. That's fine. The question then becomes, does my X mean become the new X low or the new X high? Well, if it's the new X low, that means that my window is going to be like this. Where's the root? The root is not in between those two. So X mean cannot be the new X low. Instead, X mean is going to become the new X high. This is going to become the new X high in this example. So we had a case where X low is replaced. We just had a case where X high is replaced. The final case is that we find the root. So if I were to have a function that or something, and I say, okay, here's X high, there's X low, and I get X mean to be perfectly at this point. If that's equal to 0, we're done. We found it. And we're good. That's the general idea behind this method.